So now it is visible, na? Screen is visible, na, sir? Full screen visible, sir? Full screen. Hello?
Yeah, fine.
Okay. Now we can start, sir. Now we can start. I'm admitting all. 1 minute, sir. Shiva Sankar, sir, please unmute yourself. Sir, please unmute. I have muted all participants. Okay, right. So now we can go ahead, sir.
A very good morning to all the participants. This is Leela Prasad, Head of Mechanical Engineering Department at Vigyan Institute of Technology and Science. I welcome all the participants and also the today's resource person, Dr. Shiva Sankar, sir. To this 1 week FDP on optimization techniques for mechanical engineers. Actually, this FDP is a brainchild of our faculty, Dr. Singar sir. He did everything, including identifying apt resource persons. I have to appreciate his efforts. Thank you very much, sir. I also have to thank the mechanical department HOD at Vigyan University and the at Vigyan University, Dr. Suvarna Raju sir, and the resource person, Dr. Rao sir and Dr. Ratnaraju for their contribution to this FDP. Thanks to all of them. About this FDP, as a faculty at some point of time, we have to use optimization techniques, like in our research works, and also while guiding our students for their PhDs or MTechs or BTech projects. One thing that is missed out in this FDP is a session on Taguchi method, which we will cover through a webinar during next. With this few opening remarks, include it here. Thanks once again for all the participants as well as response, and let us hope this FDP will be helpful to all of you. Thank you so much, sir. Sir, please go ahead. Dr. Singarwell, sir.
Thank you, sir. Good morning to one and all. This 1 week FDP on optimization techniques for mechanical engineers. The day 1, entropy based gray relational analysis. The resource person is Dr. S. Shiva Sankar, currently working as assistant professor in Government College of Engineering, Sengipatti, Thanjavur, Tamil Nadu. And Sir completed his bachelor degree and master degree from Anna University and a PhD from NIT Trichy, National Institute of Technology, Tiruchirappalli. The SAR have more than 20 research publications and organized various FDP short-term workshops and given various lectures in machining areas. So welcome, sir. Welcome once again. Take over the session. Please take over. Sir, unmute, sir. Shiva Sankar, sir. Please unmute yourself.
Yeah, thank you.
Sir, you can continue.
First of all, I thank the management of Vigyan Institute of Technology and Science, Hyderabad. I thank Professor Neela Prasad, the head Department of Mechanical Engineering, for giving me this opportunity. I personally thank my dear friend Dr. B. Singaravelu. He is very close to me for the possible lecture. I readily accepted ideas with you. In that aspect, I welcome all the participants on entropy-based relational analysis. Very good morning to all. Most of you, I think, faculty from right. You might be finishing your PhD, or some of you might be undergoing your PhD program. If you conduct any research or any experiments, it is end up with a solution or a result, right? To give a correct result, which will be accepted by the technical society, we need some quantitative techniques in order to justify our results. So for that case only, normally we are going for the optimization algorithms. There are variety of optimization algorithms nowadays available. This is very simple algorithm what we are going to discuss in the remaining 1 hour, that is called entropy based relational analysis. It is very simple algorithm. It can be solved by means of Excel. So this is the algorithms, that is entropy based relational analysis. We are adding something to the relational analysis. You know very well what is relational analysis. Beyond that, we are adding something to that is called entropy. So relational analysis is a technique which is found out by Professor Zhuang, a Chinese professor, during the year 1982. Right? With that, we have adapted some more techniques that is called entropy. We are going to discuss about what is entropy, how to calculate, and everything we are going to discuss. Next slide. Yeah, in this today presentation, this is my content, that is a relational analysis introduction, the significance of entropy. I have taken my own experiments to explain this entropy based relational analysis. This is the experiment I have conducted during my PhD program at NIT Tiruchirappalli. The equations and everything. Finally, we have 2 Excel sheets, worksheets that I am going to explain you. Finally, the results are presented with the support of ANOVA, and then it will be end up with some ranking of experiments. Right. Next. Next. Yeah. The gray system. What is the gray system? Right. If you look at the meaning, previous slide, sir. Yeah. Gray system, right? Gray system, you know very well. Next. Yeah, this one, exactly this one, right? The concept of gray system, right? So in the gray systems, there is no complete clarity. That condition is known as gray, right? If you take any system which can be used for modeling, we need a complete set of data. But in the gray system analysis, even in some zone, if the information is not known, the system, it will manipulate and it will find the output. That is the main advantage of this gray systems, right? If you say normally gray color in the sense it is not completely black or completely white or completely red, right? It is a mixture of a color that is referred as gray, right? Here also, in this particular system, there are some portion where the information is not known. That portion is called a black portion. There is some portions where the information is completely known, that is called white. The area the information is known, that is referred as white. The area where the information is not known, that is referred as black. Now, the gray system will combine these 2 regions and it will give the output with respect to the input. How it gives? It do number of iterations. It depends upon the value of input depends upon its repetition, depends upon its occurrence. Based on things, it will do number of iterations, then it will create the link from input to output. It assigns the weight to each link. Finally, the output is coming. This type of system is called gray system. Next. Yeah. Normally, in gray relation analysis, we are assigning the equal weights to all output characteristics. In any experiments, there are two things are important. One is input parameters, another one is output responses. In between, there is a process. So any process, it will be started with input parameters and it will be ended with the output responses. To connect these input parameters with the output responses, we need a system or we need algorithms, right? So your gray relation analysis will perform the function. It means it will correlate the input parameters to output responses and it will find the optimal solutions. Sir, audible? Singaravel, sir? Singaravel, sir?
Yes, sir. Yes, sir. Continue.
Yeah. Okay. Now, to explain the complete details of gray relation analysis, I have taken my own experiments, right? The title of my research, a portion of my PhD research is the machinability study on electrical discharge. Here, I have taken the workpiece, that is, I have performed some machining operation over that material. Since that material is very hard in nature, it is not possible to control the direct contact between the tool and workpieces. The best unconventional machining for this particular material is electrical discharge machining process. My aim is to study the machinability behavior of this particular material through electrical discharge machining. To conduct any experiments, we need to design the experiments. Designing experiments means how many parameters we have to take as input, called a design of experiments. Here, I have taken two parameters. One is called pulse on time. Another one is called tool material. There are so many factors are normally considering for electrical discharge machining process. But this is my only the preliminary study. Here, my objective is to select the best tool material. So that I have restricted only with the tool material and pulse on time. Pulse on time, you know very well. Normally in electrical discharge machining process, there is a workpiece and there is a tool. Workpiece and a tool both should be the conductor. Now the power supply is given between the tool and the workpiece. Therefore, the arc is produced from the tool and it is focused on the workpiece. Both the tool and the workpiece are submerged in dielectric medium. Dielectric medium which will pass through the arc, which will pass the arc from the tool to the workpiece, so that the arc is focused on the localized region. In the localized region, the workpiece melted and it is eroded. That is the principle of electrical discharge machining process. So, what is the shape of the tool you are having? The same shape will be eroded on the workpiece, right? So, pulse on time means the production of arc. There is another parameters that is called pulse of time. Pulse of time means there is a time period during which there is no arc. That is called pulse of time. The electrical discharge machining is concerned, right? Another one is the tool material. Tool material is also very, very important. Some properties like it should have very good thermal conductivity. It should possess higher melting point. It should possess higher electrical conductivity. These are the important parameters of your tool material. So that my objective is to optimize the tool materials as well as to optimize the pulse on time for this particular case. Next. Yeah, this is the specification of machinery what I have used for my study. Next. Yeah, these are all the photographic view of 10 different tool materials like titanium, graphite, niobium, tantalum, tungsten, molybdenum, nickel, stainless steel, copper, and silver. So I have taken 10 different tools and 2 levels of pulse on time. Therefore, totally 20 number of experiments. 10 into 2, 20 number of experiments, factorial design. Sometimes huge number of experiments. Normally we hear only 20 experiments. Therefore, I have gone for full factorial design. Then, so all these tool materials having the diameter of 2 mm. These tool materials are manufactured by means of various process. Like some tools are manufactured by means of machining. Some tools are manufactured by means of extrusions. Like that, we have produced 10 number of tools of same diameter. But you look at this picture, the tools are varying in length, right? Because only the diameter is a matter to produce a hole of the diameter of the tool as a constant affect the process capability. Therefore, that we kept as variables. That is no issue, right? Then next slide, sir. Next.
1 minute, sir. He will change. Anup, sir.
Sir, Leela Prasad, sir.
Sir, I have changed the slide. Is it visible?
No.
No, sir.
Now okay.
Now okay.
Okay, now coming now.
Shiva Sankar, sir, is okay?
Yeah, it's coming, but you have to change the slide. No.
Before that, another one slide was also there. This one.
Tools only there, right? I need another. Yeah.
This one, right? Okay.
Shiva Sankar, sir, the slide okay? Or we have to change the next?
No. You go previous slides.
Previous.
Is it visible? Previous slide?
No,
No, it's
Not
not.
yet.
Yeah. No, not it.
It's
Yeah.
not
Go to
on.
next slide. Yeah, tool material. Correct. Next. Fine. Okay. So output responses. We have taken some 6 output responses. In order to study machinability of any material, we need some measure, right? So, for example, remold rate. You know very well that how the material remold rates are calculated. That is, we weigh the workpiece before machining and we weigh the workpiece after machining. And when it is the difference is divided by means of the time taken, that will give MRR, that is material remold rate. So another thing which is used to express the measurability is tool wear rate. That is also a very, very important factor. Here the tool wear rate is calculated by means of weight based. That is the weight of tool before machining minus weight of tool after machining divided by machining time. Another thing is weight wear ratio to the material removal rate. Next. Yeah, next slide, sir. Yeah, you are right. So another thing is the roughness. Roughness also very, very important for any machining process to find the roughness value. Normally, when the hole in our case, the hole diameter is only 2 mm, right? So it is not possible to use the conventional roughness measuring device because the probe itself, it is 500 micrometer, but our hole diameter is only 2 mm, right? So that it is very difficult to make the surface profilometer to travel over the internal surface of the hole. That is the first thing. Another thing is our material is ceramic in nature, therefore it may damage the tip of the tool of the surface profilometer. In order to avoid these two things, I have gone for some image processing techniques, right? By means of image processing techniques, I can able to calculate the roughness value of the concerned hole, right? So these are all various stages. The first one is image acquisition by means of video measuring machine. That image should be converted. Then there is the image inversion. Image inversion means converting a colored image to black and white image. Then edge deductions, then finding the center line, the slope, then rotate the image, roughness calculation, image interpretation, right? Next. Yeah, next.
Sir, can you see this slide? Image capturing equipment. Is it the slide name, sir? Hello? Hello?
Is he there?
Hello?
Shiva Sankar,
Am I
sir.
audible?
Anup, you are audible. 1 minute, Shiva Sankar, sir. Resource person, some problem.
Image capturing equipment is coming, no? Right?
Yeah.
Yes.
Okay.
His audio is disconnected. He is in mute. Shiva Sankar sir is in mute.
Sir.
Requested.
Yeah. Okay, sir.
Okay, sir.
Yes, audible, sir.
Yeah. Fine, sir. Okay, this is the video measuring machine. What you are looking in the picture, there is a machine. In that we are placing our workpiece so that the image is captured. The image is converted into colored image. Then the colored image is inverted. It means black into white or white into black. That is called image inversions. Finally, there is the image we are capturing. That image is entered to the MATLAB. By means of MATLAB coding, we could be able to find the roughness value. That is okay. Next. Yeah, next, sir. Hello.
Sir, change.
Yeah. So this is a various of this is a various stage of finding the roughness of a particular machined component. The first topmost figure shows a number of holes which is created on that workpiece. Third image shows the inner portion. Once the holes are manufactured, the holes are splitted so that we could be able to see the inner portion of the holes, right? Fourth portion of the hole, right? In the side view, there is a number of straight lines there. That is reference. The distance between each line is 1 mm. Based on this reference, we would be able to calculate the original size of the image. Next. Next, sir. Yeah. Now the particular there is the image inversion. It means the colored image are converted into black and white. The next figure, that is we have cropped only one edge to find the roughness value. Now at this stage, the image is fed into that MATLAB. Now fourth figure shows the MATLAB screen. In that MATLAB screens, we have which we could be able to find the roughness of this particular line. Next. Hello. Yeah. Okay, this is the correlations. Next. Yeah. So roughness measurement by means of peaks and valleys method, we have calculated the roughness value. It is okay. Then. Yeah, roundness is another parameters which is used to calculate the machinability behavior of EDM. Because roundness normally one of the main roundness, right? So how can you define the out of roundness means the profile. This is when the profile is enlarged, you may able to find the imperfections in that profile. Actually, it should be round, but there will be the imperfections, right? Now we are drawing two concentric circles, one at inside, another at outside, right? Both will just touch the profile, right? Now the radius difference between these two circles are called out of roundness. Sometimes it is simply referred as roundness. Then next. Yeah, this is also calculated by image processing. The similar techniques. The first diagram shows the unmachined component. Second one is machined component, and there are number of holes are there. Next. Yeah, this is the image of a particular hole. If you look at the top figure, you could be able to see the inner green portions and outer black portions. Normally in video measuring machines, there are two lights. Bottom there is another light that is green in color, right? Because normally the hole which is produced by means of EDM process is normally tapered in nature. Therefore, what happened when the green lights are coming from the bottoms, that will be in green color. The other portions, the tapered surface will be reflected as in black color, right? The bottommost figure is the cropped view of the outer profile. Next. Next, yeah. This is the final image that is fed into that MATLAB. Now your MATLAB will give the out of roundness by means of some coding. Next. Yeah, this is a taper angle. It is one of the responses, diameter at the bottom, and the thickness we can able to measure. Based on these three things, we can able to calculate what is the taper angle. Yeah. Now there are two input parameters like the tool materials. There are 10 levels, and another input parameter is pulse on time. That is two levels, 7 microseconds and 11 microseconds. So totally 10 into 20 experiments, and 6 output responses like MRR, tool wear rate, weight wear ratio, roughness, roundness, and a taper angle. Now our objective is to find the optimal solution using relation analysis in adaptation with entropy. Yes. Next. Hello. Next. Yeah. These are all the holes which is produced by means of 10 different tools. Okay. Next. Yeah, these are the tool. Once it is machined, there is the wear on the each tool. It depends upon the strength of the tools, wear natures. There may be damage on that workpieces. That will vary from one tool to another tool, right? Next, next, sir. Yeah, next. Yeah, now actually we entered to the topic, right? Yeah. Previous slide. Yeah. So entropy based relation analysis, this is the various steps in this. First, the data should be normalized. What is the need of normalizations, right? So normalization is nothing but converting the real data into the values from 0 to 1, right? Why the normalization is done means in order to impart the equal weightage to all the parameters. Say for example, if you take two cases, that is MRR and the roughness value, or MRR and the roundness value. If you take MRR, that is measured in milligram per minute. Normally in EDM process, the MRR may be 0.1 milligram, 0.5 milligrams, or maximum of 1 milligram per minute, right? But if you take the roundness value, it may be in terms of hundreds, right? So one quantity is less than one, and another quantity is in terms of hundreds, right? So if you substitute the same value to the algorithm, what will happen? It gives more importance to what is that? The roundness, because the roundness value in terms of hundreds, but it gives very least importance to the MRR because the MRR value normally less than 1, right? So in order to give equal weightage to both the parameters, so this value should be normalized. It means all the values should be converted such that it has the range from 0 to 1. So normalization is a process by which all the numerical values are converted into from 0 to 1. That is the purpose of normalization. Another stage is data processing. To get the gradation coefficient, we need some process. Say for example, in this case, I used S by N ratio to calculate the gradation. Then the calculation of gradation coefficient. Then there is a term that is called entropy. Quantity, we can give the variable weight to each output responses, right? That quantity is known as entropy. Another one is determination of degree of diversifications. Degree of diversifications means how a particular value is deviated from its ideal value. That is called degree of diversifications. Normally, what is the value you are finding? That value is subtracted from 1. 1 is the whole number. What is the value you are getting? That should be subtracted from that 1. That is called degree of diversifications. Another one is determination of weight of the criteria. Normally in gradation analysis, we are assigning equal weights to all responses. Say for example, if in this particular case, if we apply normal gradation analysis, means we have to assign weight to each output quality characteristics. For example, there are 6 output. Therefore, 1 divided by 6, that is equal to 0.166. So 0.166 should be allotted for each quality characteristics. It means 0.166 for MRR, 0.166 for TWR, 0.166 for WWR, that is weight wear ratio. Like that, the same is assigned for roughness, same is assigned for roundness, same is assigned for taper angles, right? But in entropy based analysis, we are finding the new weights. That is a newer thing. Then finally, we have to calculate the gradational grade. Based on gradational grade, we can get the best experimental condition. Next. Yeah. So this is the steps to find the weights, right? So first, the x of I means the value of the input, the value of a particular output, right? Where k is called the number of responses. Here in this particular experiment, the value of k is 6 because we have taken 6 number of responses. Okay, and m is the number of experiments. For this particular case, we have 20 number of experiments. Therefore, the value of m is equal to 20. From this, we have to calculate the dk value. It means we have to sum up all 20 values. Then we have to calculate dk values. From this dk, we can able to calculate ek. From this ek, we can able to calculate the summation of these things. That is called entropy E. From this entropy, we can able to calculate the lambda. That is 1 divided by m minus e into 1 minus ek. From this, we could be able to calculate the weight of each output quality characteristics. Here I have one Excel sheet. From this, you can able to get a clear idea. Next. Yeah. Before that, we need to formulate a piecewise equations. That is f of x minus y naught is equal to m into x1 minus x naught, where the limits of x is from 0 to x1, right? It is simply in the form of y minus y1 is equal to m into x minus x1, right? To find the limit of x, we have to divide the interval of x may be calculated by means of 1 divided by number of experiments, right? Here 1 divided by 20. It means we have 20 number of experiments. So each interval of x is equal to 0.05. It means it will vary from 0 to 0.05 for first case. For second case, 0.05 to 1. Third case, 0.1 to 0.15, like that it will go. Next. Yeah. So number of piecewise equation is equal to number of experiments, right? So limit of x for first equation, that is from 0 to 0.05. For second equation, the limit of x is 0.05 to 0.1. For third equation, it is 0.1 to 0.15. For fourth equation, it is 0.15 to 0.2. Like that it will go. For 19th equation, it may be from 0.9 to 0.95. For 20th equation, it is 0.95 to 1. Next. Yeah. So we have to find the value of y, right? So there is the equations for y. The y is equal to 1 by e power 0.5 minus 1 into y of x, right? There is another equation to calculate y of x, that is equal to x into e power 1 minus x plus 1 minus x into e power x minus 1. Initially, we have to put the value of x is equal to 0. Therefore, y of 0 is equal to 0 into e power 1 minus 0 plus 1 minus 0 into e power 0 minus 1. Finally, we'll be getting 0, right? So you have to substitute y of 0 in the previous equation. That is, y is equal to 1 divided by e power 0.5 minus 1 into y of 0. Y of 0 is 0. So naturally, the total value of y becomes 0. Next. Yeah. Then we have to put another limit to find the value of y. That is value of y at x is equal to 0.05. When x is equal to 0.05, y of 0.05 is equal to 0.127985. We have to substitute this value over the below equation. Then we would be able to find the value of y. That is equal to 0.19730. Yeah, next. Yeah, now, yeah. Few seconds. Yeah, fine. Value of x as well as the value of y. Now the slope can be calculated by means of y2 minus y1 divided by x2 minus x1. That is equal to initial value of x and y we kept as 0, right? So by means of putting the value of x is equal to 0.05, we would be able to find the value of y. For that case, the value of y is equal to 0.19730, right? So for the value of x is equal to, would be able to find the value of m. Yeah, m is equal to 3.94. Next. Yeah, next. Yeah, like that we have formulated some 20 number of equation. If you look at the first equation, f of x minus 0, because the value of y is equal to 0, that is equal to the slope, just we have calculated x naught 0. First equation is finished. The second equations, f of x minus 0.19730. This is the value of y with respect to the value of x is equal to 0.05. Clear? Right. So far, so right. So in this equation, we have calculated the value of x is equal to 0.05 for second equations, right? Second equations, right? For second case, the value of m is equal to 3, right? By means of value which corresponds to 0.1, that is 3.47310. It means that to calculate the value of m1, we need x1 and x0. Similarly, y1 and y0. To calculate m2, we need the value of x2 and x1. Similarly, y2 minus y2 and y1. Like that, we can able to formulate 20 number of equations. Next slide. Yeah. Before that, you please go to that Excel sheet, sir. Excel worksheet. Excel sheet, sir. Please open Excel sheet.
He will open, sir. 2 minutes. He will open.
Yeah. No problem. There are two Excel sheet. You please open the weight. There is a Excel. Yeah. Exactly. You are right. Right. Yeah. Please zoom, sir, so that just to cover the first tabulation. Just to zoom, sir. Yeah. Yes. Yeah. If you look at the first tabulations, it is simply the responses of what we observed, right? Yeah. Yeah. Please come down, sir. Come. Yeah. Now you see the formula, that is dk is equal to summation of xk, right? So there are 20 x values, 20 x values for MRR. All these 20 values should be added. It gives the value of dk. Similarly, we can calculate the dk value for TWR, dk value for weight wear ratio, dk value for roughness, dk value for roundness, pk value for taper angle. So that we have now 6 dks. The next tabulation, sir. Next tabulations. Yes. Yeah. This is called xi by di, right? So for example, if you click the first cell of MRR, sir, please click first cell of MRR. No, yeah. Now you can see the formula. That is a particular MRR divided by the value of dk for MRR. The value of dk for MRR, you please go to previous table, sir. At the bottom. Yeah, come down. Yeah, you see this value, you know, 40 something 11.0139. This is the value of decay for MRR, right? So please you keep this value in mind, and now you go to second table, sir. Go to first cell of MRR. Yeah. Now you see a particular MRR divided by decay, that is 11.3 something, right? Similarly, all the values are calculated for MRR. That is called XI by DA. Now you please keep on the first cell of TWR, sir. First cell of TWR. Yeah, you see the formula, a particular TWR divided by the summation of DWR. Okay. Like that, we would be able to calculate the values of all parameters, right? Yeah, fine, sir. 16 point. Yeah, you please click, sir. First cell. First cell of TWR. Yeah, second table, first cell of TWR. Yeah, the particular value divided by the summation of TWR, which you found out from the previous tables. Like that, we could be able to formulate XI by DI values for all the values. Go to next, sir. Next table. Next third table, sir, please. Yeah.
Excuse me, Devaprasad sir, please look into that. Some people are causing disturbance. Please mute.
Yeah, in the third table, you please look at the third table. You use the value of f of xi by di. F of xi by di. Sorry, please listen. In the previous tables, we have calculated xi di, right? Now we have to see where this value is exactly situated. For example, if the values of xi and di is suppose, say for example, 0.042, for example, 0.042. This 0.042 is coming between 0 to 0.05, right? It means that we have to select the first equations to calculate the function of xi and di. That is very, very important, right? You please go to previous table, sir. Please go to previous table. Yeah, there are color difference. You see, sir, there are color difference, right? Say for example, if you see the first three values of MRR, same color, 0.0935, 0.0627, and then third one is 0.06 something, right? So all these three values are coming from 0.05 to 0.1, 0.05 to 0.1. So for this case, we have to use the second piecewise equation to calculate the value of function of xi and di. Clear? It means that just we have to substitute these values of x in that particular equations. From that value, we can able to calculate the f of x. Now, can you able to go to PowerPoint, sir? Is it possible? Yeah, previous. Yeah. Now, what is the value of this 0.06 something now? So that we have to use the second equations, right? In the second equations, we have to just substitute instead of this x value, we have to substitute. That's all. Very simple. Other things are constant. 0.19730 constant, 3.42 something constant, and then 0.05 constant, right? If you substitute that particular value for this x, we would be able to find the value of f of x. Clear, sir? Anyone of you reply? Singaravel?
Yes, sir. You can continue, sir. During question section, we can.
Okay. Yeah, just we have to calculate xi by di. and we have to identify that in which interval it comes. Based on that, you have to select a piecewise equation. In that particular equation, we have to substitute that xi by di value in the place of x. Okay, so that we can able to calculate that f of x. Right? Okay. Right. Now you go to that worksheet. Please go to worksheet. Yeah. Yeah. So in this there are different colors na. It means that gray color or blue color depends upon the interval in which it comes. Sir, please come down. Please come down. Yeah. Yeah. Please. Still comes down. Please come down. Yeah. Yeah. See here, there are different colors na. Yeah, just move equation number 1. Yeah, the blue color. So what are the numbers which is present in this blue color? That is coming in the first interval. Therefore, we have to use equation number 1. The numbers which is in this particular color, that is the maroon color, we have to use second equation. It means that values are coming from 0.05 to 0.1. So we have to use second equation to calculate f of x. Similarly, in yellow color, so that values are coming from 0.15 to 0.2, like that. Okay. So like that, how many readings we are having? There are 20 experiments. There are 6 responses. Therefore, 6 into 20, 120 outputs are there, right? So 120 outputs are coming. All should comes within this piecewise equation range, right? So here 73 readings are coming in the first category. So that we have to use the equation number 1. Some 40 readings are coming in the second category. So you have to use equation number 2. Remaining 3 readings are coming for third interval. 1 reading is coming in the fourth interval. 3 readings are coming in the fifth interval. Right? So that depends upon the values where it comes. We have to use that particular equations. Yeah, you can add. Yeah, 120. Good, very good, sir. So 120 coming, right? Okay, next. So what I mean, so we have formed some 20 equations, but we have used only 5 equations for this case. So it doesn't mean that we have to use all 20 equations. That depends. That we cannot say that we have to use this number of equations, we have to use this number of equations, right? So we have formulated 20 equations. Where the values are coming, that we don't know. Depends upon the occurrence, we have to select the equation. That's all. Okay, next. Yes. Next table, sir. Third table. So f of xi and d we have calculated. Then please come down. Yeah, please come down, sir. Please, sir. Yes. Yeah. It is very simple, sir. We have to sum up all this column. We will be having the value of ek. So we will be having some 6 ek values. So we have to subtract this ek value from 1. So we have 6 values, right? Go to right, sir. Right end. Yeah. Right. So summation of all E suffix k is called capital E. This capital E is known as entropy. Okay. Right. Yeah, please come down, sir. All are simple calculation, right? You go to yes. You are right. So from this, yeah, fine. So we can able to calculate lambda k. Lambda k is equal to 1 divided by m minus e into 1 minus ek. 1 minus ek already in the previous cell we have calculated. The value of m is equal to 6 because there are 6 responses. Therefore, the value of m is equal to 6. E is nothing but the summation of ek. All, if you sum up all 6 ek, we can able to find the value of e, right? So from this we can able to calculate lambda k, right? Right. Now, if you add all lambda k, we would be able to calculate sigma lambda k. From the sigma lambda k, we could able to beta suffix k. Now the beta suffix k is called the weight. Okay, you see the weight for first output, that is it is 0.1511. For weight for ratio is 0.1734. For round taper angle it is 0.17. Square weights 0.166, 0.166, 0.166, 0.166, like that for all responses. Now in this entropy methods, the weights are given by its own. We are not performing anything. Depends upon the occurrence, depends upon the occurrence. It is automatically calculating its own weight. Clear? Clear, sir? Okay. Okay. Next. Yes, sir. Fine, sir. Now you go to PowerPoint, sir. Hello. Yeah. Go for yeah. Next. Yeah. Please correct. Okay. So we have calculated the weight. The one portion is finished. We have calculated. This is portions which is used to calculate the relational coefficient. Relational coefficient. If you multiply the relational coefficient with the weight what we have calculated, we could be able to calculate the relational grade, right? So this is a normal procedure to calculate the relational coefficient. Here, by means of S by N ratio, we have calculated. There is a formula for S by N ratio. There are two equations for to calculate the S by N ratio. If it is lower, the better. We have to use first equations. That is minus 10 log 1 by n into sigma sigma y square. Then higher the better. It is minus 10 log 1 by n sigma 1 by y square. Right. This is a common formula by which we can be able to calculate S by N ratio. Then the value should be normalized by means of the bottom equations. That is maximum minus a particular value divided by maximum minus minimum. Maximum means the maximum value of a particular response. Say for example, the maximum value of MRR. Minimum means the minimum value of MRR, right? Like that, all the data are normalized. Next. Yeah. This is a formula to calculate the gradation coefficient. That is gradation coefficient is equal to del minimum plus tau into del max. Del minimum means the minimum value of that particular parameter. Del max means the maximum. Del minimum means the minimum value of normalized value, that is 0. Del max means the maximum value of normalized value. Normally it is 0. Del max is 1, right? This tau is taken as 0.5. That is called a distinguished coefficient. Normally it is taken as 1. Sorry, 0.5. Then next, sir.
Sir, is it visible, sir?
Anup,
Sir.
it's visible, but resource person may be disconnected.
Yeah, looks like it's disconnected.
You unlock lock. Actually, participant is locked now. Make it unlock.
Okay.
Maybe he will try.
Okay.
Thank you.
Unlock. Therefore, sir, please take care of it, sir.
Yeah, let him
Please
enter.
accept it. Okay.
Say yes, come.
Okay.
Sir, audible, sir?
Now audible, sir. You can continue.
Yeah. Yeah, fine. Yeah, sir, please open that. Yeah, audible, sir?
Yes, sir. Audible.
Yeah, fine. Yeah, please open another Excel worksheet, sir, please.
One minute, sir. He will open.
Yeah, fine. Yeah, fine.
అలా అసలు స్లాట్ చేంజ్ అనేది యాక్సెప్ట్ అయితే నేను ప్రయర్ ఇంటిమేషన్
Hello.
Yeah,
Tell
fine.
me, Anu.
Yeah, is it visible?
No.
Somehow your screen sharing is paused. One second. I'm trying. It is GRG, right, sir?
Yeah, fine, sir. Exactly. Yeah.
Sir, is there anyone trying to share it?
Which Hyderabad has started screen sharing.
Okay. It's still not visible, sir.
No, not visible, sir.
No, not yet.
I have already shared it, but somehow message is coming like your screen share is paused. Sir, Devaprasad, sir, is it possible from your end to share the screen?
No, I don't have any link here. Hello?
Hello.
I don't have any link here.
You don't have the PPT with you, sir?
Yeah.
Shall I send you?
Yeah, you can send it to WhatsApp.
Admission
Shiva Sankar, sir.
Yeah.
Before screen share, you can mute, sir. Papa Kiriti. No, sir.
Anup, did you send through WhatsApp?
I'm sending, sir. Send, sir.
Excel file.
Excel, yes, I have sent.
You may start now.
Received, sir. Shiva Prasad, sir.
Yeah. Can you see the screen? Yeah, can you see the screen?
Sir, okay. You are using mobile, sir.
Yeah.
Shiva Sankar, sir, unmute.
Sir, please keep in landscape mode, sir.
Yeah, I could able to see, but yeah, fine. Yeah, nice. Yeah. Okay, sir. Fine, sir. Go to first table, sir.
This is the first sheet only, sir.
First table left.
First sheet only, sir. This is the first sheet and first
Yeah.
corner only, first cell.
Yes. It's actually. Yeah. You are fine. Yeah. See, sir. There are 20 experiments are formulated like that. Experiment number, then tool, pulse on time, pulse of time, right? So for the first 10 experiment, the pulse on time is 7. For the second 10 experiments, that is from 11 to 20, the pulse on. It means each tool are used for 2 experiments. Each tool used for 2 experiments. Then we observe MRR taper angle. Go to second table, sir. Second table.
It is only one table in second first. Yeah. Sir, can you see the descent ratio?
Then second table, SPL ratio. You please keep in first cell in MRR. Please select the first cell in MRR. Yeah, you see the formula, that is SPL ratio for this particular case, that is equal to -10 into log 1 by the square of that particular value. Like that, SPL ratio is calculated for all 20 values of MRR. You please keep in the first cell of TWR. Yeah, -10 log the square of that particular value. In the previous case, -10 log 1 by square of that particular value. Here, -10 log the square of that particular value. Because in the case of MRR, it needs to be maximized. For TWR, it should be minimized. So for TWR, lower the better. For MRR, higher the better, right? So that we have 2 different formula to calculate the SPL ratio. One for higher the better, another one is lower the better. Like that, we for all other parameters, lower the better, except MRR, all TWR, WWR, roughness, roundness, and taper angle, lower the better. Therefore, we are using the same relation to calculate the SPL ratio. Fine. Go to next one, sir. Next table. Go to next table.
Yeah, normalized
That
value.
is normalization. You please keep in the first cell of MRR, sir, please. And that is equal to a particular value minus the minimum of these SBL ratios. The minimum SBL ratios of MRR divided by the difference between maximum and minimum, right? Next, sir, the first cell of TWR.
Yes, sir. Yes, sir.
Here, we have to take the maximum value. Yeah, maximum value maximum and minimum. We would be able to calculate the normalized value. Similarly, we can calculate the normalized value for all 20 TLWR. Then WWR, that particular value minus, that is the maximum value minus that particular value divided by the difference between maximum and minimum. Like that, all the data are normalized from 0 to 1. Next table, sir. Yeah. Diversification point is nothing but, sir, actually, if everything is all right, so that is an inversion, black into white and white into black. Therefore, all these values are subtracted from 1, sir. Therefore, if you get the value of 1 means here it comes 0. If you have the value of 0.5, here it comes 0.5. If you have the value of 0.6 means here it comes as 0.6, right? You please keep in the first cell of MRR, sir. Diversification point. That is one minus the previous value. That's all. Everything same. Please keep the first cell of TWR. Simply 1 minus something, that particular value. Like that, we can able to calculate the diversification point for all the values. Please go to the next table, sir. So here, that is a gradation coefficient. Please keep in first cell of MRR. So that is nothing but del minimum into diversification coefficient into del max. That is a formula already we discussed. Here del minimum is taken as 0 because the value, the normalized values are varying from 0 to 1. Of normalized value 0. So del minimum is taken as 0 and del max is taken as 1. Therefore, your formula becomes like this: 0.5 divided by 0.5 plus that particular value. Right. The same equation is true for all 20 values. You please put in first cell of TWR, sir. Here in the top we have only 0.5. That is because TWR is lower the better. Equation just reverse. For MRR, higher the better, right? So using this equation is calculated for all 120 values. Next table. Sir, next table, sir. Next table, yeah. Next. Next. Wait. You see? Beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. All these values are already we have calculated using entropy method, right? Then next table, sir. Next table, please keep the first cell of MRR, sir. First cell of MRR.
Yes.
So this is nothing but the weight of MRR into the gradation coefficient of MRR. Clear, sir? So gradation coefficient is calculated for all MRR. Similarly, you please select the first cell of TWR, sir. First cell of TWR. Please select the first cell of TWR. Yes. So this is nothing but gradation coefficient of TWR into the weight of T. The weight of TWR. Like that for WWR also, the product of the coefficient of the particular value is calculated. Like that, we would be able to calculate all 120 values. The last, sir. Now these all 6 values are summed up. You please put here, sir, 0.50. No, here. Point, yeah. That is equal summation of all 6 values. That gives relational grade. Similarly, all 20 experiments, then depends upon its value, these experiments are ranked. Right? Say for example, highest values go to the first position. Next, the highest values goes to second positions. Like that, the lowest value goes to 20th positions. Right? Like that, we can optimize the process. Say for example, here 0.8462 is the highest value of all 20. Therefore, that gets the position of 1. It means this particular experiment gives the optimal input parameters. Say for example, but in the same horizontal line, you please come forward left. Yeah. Yes. Left. Go left in the same cell. Yes. Yeah. Same cell. Yeah, it means that AG and 7. Yes, sir. AG is the best tool and 7 is the best pulse on time. Clear? Okay. Go to right, sir. Go to extreme right, sir. Yeah. Extreme. Yeah. Yeah. Top. Stable top. Yeah. Here you see, this is a gradational grade into coefficient into 0.166. Just for comparison. In previous case, each quality characteristics are multiplied by means of the weight which is given by means of entropy. But in this case, the gradation coefficients are multiplied by means of equal weight, that is 0.166, right? So now gradation coefficients are calculated. Move, sir, next. Yeah. Now this is a new gradation grade which is given by means of equal weight. This is also ranked. But here the second experiment is taken as the best one. Clear? Now, in order to compare these two processes, that is by means of assigning the equal weight, then by giving the weight by means of entropy based gradation analysis, right? Now I compared these two processes by means of S by N ratio. Please come down, sir. Please come down. Yeah, I have calculated the S by N ratio for this case as well as for this case. Please move left. Yeah, here it is coming 21.3351, but in this case it is coming something 21.28. So from this, I can prove that our methodology is somewhat accurate and accurate, and the error is less when compared with equal weightage methods. Okay, sir. Right, that's all about. Then finally, percentile, right? Okay, sir. Thank you. I think now I come to the end, and now if any clarification, I would be able to clarify.
Yes, Singarwal, can you please go ahead?
Thank you, sir. Shiva Sankar, sir. Yes, sir. Shiva Sankar, sir.
Yeah, fine.
It's audible, sir. Shiva Sankar.
Yeah, fine. Audible.
Nice presentation, sir.
Yeah, audible.
We have few questions. Entropy technique is used as Shannon entropy.
Yeah.
The same procedure. Yes, sir.
Okay.
One of the participants asked this, whatever you are explained entropy is a Shannon entropy method or not? Yes, only. Okay. Second,
Yeah, there may be the name may be Shannon. Okay, bye. Yeah, it may be.
okay. And another question, in GRA, in gray relational analysis, compulsory we have to use S/N ratio, or without S/N ratio we can proceed normalization.
No, we can proceed. No need of SPN. Even without SPN ratio, we can proceed.
Okay.
No issue.
What are the What are the other methods to find weight, like entropy? Any other methods are available or not?
Yeah, there are so many methods are there. PSO algorithm, GA algorithm, we can use to find the weight. By using MATLAB coding, we could be able to find.
Okay.
This is a simple method. Only by means of Excel sheet, we could be able to find the weight. There are other methods also, like the PSO and the GA also, we can able to find the weight. But for PSO and the GA, we need some software support like MATLAB. Here, there is no need of any software support.
Okay. Sir, what is the coefficient value of the 0.5? The distinguishing coefficient, eta something, there is a 0.5. How to assign 0.5 or some other value?
Generally, yeah. No. Normally they are taking 0.5. What we assumed that is the mid values of the normalized range. The mid values of normalized range. Normally, the normalized value have the range from 0 to 1. So that generally they assume that value is 0.5. The mid values of the range of normalized value.
Okay. Sir, another question, what is the difference between normal gray relational analysis and entropy based gray relational analysis?
Yeah, that is what normal gray relational analysis, we are giving equal weight.
Here we are using,
say for example, if there are 6 output, here so you need not assign the weight.
Yes.
Yeah.
Okay, sir. The same procedure we can use remaining area also, like electronics or some other department also, they can utilize this procedure to automate.
Anything we can adapt the technique. Yeah.
Okay, sir. These are all the questions we are arrived from our participants. Now I will hand over to Professor Leela Prasad, sir. Sir?
Yeah. Fine.
Sir, Dr. Shiva Sankar, sir, thank you so much. The session.
Thank you, sir. Thank you for the opportunity. Yeah.
Actually, from our side, we are having some technical issues. So because of that, your session got disturbed a lot. Sorry from our side.
Yes.
So by tomorrow, we will try to overcome those technical issues. But from your side, you have given more than 100%. We are really
normally,
happy for that.
when you initiate any process,
So technical issues will be there, but today we have faced so many technical issues. Sorry for that.
Okay.
But from your side, you have given 100%. You have explained
no problem, sir. Thank you, sir.
Very well. But from our side only, there are few issues that we will overcome by tomorrow, sir. Thank you so much, sir.
Yeah. Okay. Thank you, sir. Thank you for the opportunity. I thank my friend Singaravir also, and other organizers, and a person who is sharing the PowerPoint, and meanwhile another person also support friends for their spending their valuable times, because somebody may be knowing these things already, but still they listened and they supported me. I thank one and all, sir, for the opportunity.
Right, sir. Thank you. Have a good day.
Yeah. Thank you, sir. Thank you, sir.
Shiva Sankar, sir.
Yeah.
Thank you, sir.